Okay. Good afternoon, ladies and gentlemen. It's good to be here. My name is Jan Lahoda, and I am a software developer working on the Java compiler inside the JDK. That's called Java C. I am small part of a team working on Java C at Oracle. And today I would like to talk about recent and possible future JDK features. And because I will be talking about the future, I need to show you this slide. And now, a little bit of introduction. It's basically the only slide I have. And as you probably know, the JDK now uses 6 months cadence. So every 6 months, we have a new major release of JDK. Some of these releases are long-term support releases by some vendors. These JDKs are currently JDK 11 and JDK 17. The next one should be JDK 21. There was a change before. The LTS releases were planned to be done every 3 years. Now it's every 2 years. We should have an LTS release. And because these major releases every 6 months are major releases, we can add new features to them. Basically, any new feature can be added to them: language feature, library feature, VM feature, whatever is needed. But as the cadence is pretty fast, we sometimes add the features as incubating or preview, in which case we seek feedback and adjust the features. And when they are ready, we make them final and permanent, at which point they become like a permanent part of the platform. And this all is using GeeCON enhancement proposal process. And for various features I will be showing you later, I will be always trying to refer to JEP number. And you can look into the JEP to find out more about the feature if you are interested. And I just wanted to said that we have released JDK 18 the past March, and we plan to release JDK 19 this September. And what I will be showing you is more like what are the possibilities for what will appear in 19 and beyond. There are some changes between what was in 18 and what may be in 19. So I will incline to the new approach, not to the old approach. And now, basically, a demo of features that I find interesting for some reason. And the first feature I would like to show you is actually not a language feature, not a library feature, but I suspect there may be people that don't know about it, even so it's part of the JDK since JDK 11. And that is ability to directly run a Java source file using the Java launcher. So let's consider this simple program. And traditionally, we would need to compile it using Java C and then run it using the Java launcher. Since JDK 11, we can just type Java launcher and then pass the source file into the Java launcher, and it will, on background, automatically compile the source file into memory and run the resulting class file. It can only run one file, but it's sometimes very useful. And now I would like to talk about a feature that's called records. You again may know about it. And it's a feature that allows us to easily declare classes that are holders for data. And as a motivating example, let's consider we have a class called point that has two components, x and y, and we, of course, want constructor for it. We want some accessors to get the components out of the class. We need to declare some hash code equals. And the code is not very short anymore. And if you want to add a new component to this class, if we needed to add component z, for example, we would need to augment all these. Of course, ID can help us generate this, but when we add a new component, we need to regenerate the code. Or we can, of course, use some other tool to do this for us. But since JDK 16, we can say, instead of class, we can say record, and we can just specify the components like this and delete all the stuff inside. And the meaning is basically the same. We can look at how the like methods and constructors look inside the class. We have constructor, we have equals hash code, we even have a toString with some meaningful toString, and we have accessors for the components. Now, the components in the original class were immutable, and that was not an accident. That's intentional. Records are immutable. So if we cannot like change the value of the components inside the record, we need to create a new record. And records are also implicitly static and final, so we cannot extend records. But that's fine, I think. Records are simple holders for some data that are easy to define. Now, in a sense, the methods are generated by the compiler for us, but we can override them. So if we want to, I don't know, add logging into the accessor, we can add some logging into the accessor, and we can also override easily the constructor. We don't need to repeat the components in a parameter list. We don't need to assign to some fields. We can just use this shortcut for constructor, and we can do some validation here, for example. So we can say that if component x is under 0, we throw illegal argument illegal argument exception like this. If you do it like this, we cannot create a record that would have the x component lower than 0. And that even applies to serialization, because serialization for records is also using okay, I cannot type it. Serializable. Even the serialization or deserialization of records is using this constructor. So we cannot deserialize an invalid record from a serial form. It will throw an exception. And so I think this is a nice feature that is useful. And let me switch to another, let's say, group of features that are related to strings. And the first feature is, there are language features mostly. And the feature is text blocks. And let's consider a method that should generate some HTML snippet, for example. And traditionally, we would do, or we might do something like this, some string concatenation to have the text over some lines. We need to have explicit new lines and so on. What we can do since JDK 15 is that we can use text blocks, which is basically a multi-line string literal. And we don't need to have any explicit new lines here. The new lines that are in the text block are used as new lines. there are always Unix new lines, regardless of what's written in the source code. We don't need to escape simple double quotes because the delimiter, the ending delimiter for text blocks are 3 consecutive double quotes. And the opening delimiter for a text block is are actually not these 3 double quotes at the beginning. It's the 3 double quotes and a new line after that. We cannot have text here. It's an error. There may be some white spaces and a new line. And one more important thing is that automatically the common indent of all the lines that are in the text block, which is basically this, is stripped out of the literal. It's not part of the text. Now, this is nice and useful, but what if we want to add like parameterizable part of the text? So what we can do is maybe this, some additional point, and then do some replace, like this. Like this. And this will find this text in the literal and replace with some additional stuff that we want to inject into the text. But there are several problems with that, and one of that is that it's ugly. And we will get to the second one later. So another feature that is being considered are string templates. And I don't want to use the term string interpolation because it's not really string interpolation, but it's somewhat similar. And it basically means we can type this, and we have something that is a template for a string or a string in a form of template, and then some parameters that inject values into the template. As you can see, there is an error here because the result of this is not a string, it's a template. And yeah, I should say that this is currently being considered. It's not planned for any particular release yet. But what we do with this template, we can say we want a string from this template, like this, using str dot, where str is a template policy that converts the template into a string. And this should work just fine. We can try to run it, and it should in a few seconds produce a string which has injected the template here. But there is an issue with this. What happens if I type something like this? I basically what I will inject into the string, or what I will put into the string, will contain some HTML code, or something that looks like an HTML code. Now, it will basically, written like this, it will basically textually put the value into the string, right? Which may be what we wanted, but quite often it's not what we wanted. So what we can do? We can, okay, HTML escape the value that we are passing into the template. But we need to always remember to escape some value. So the reason for this str is that we can use a different policy. So we can, for example, say that it should be an HTML string, and this is a different policy that can automatically escape all the parameters while they are being injected into the template. So if we run this, we will see that the less than symbols are replaced with some escape. The policy can also validate the input. So we can say that it's HTML validating policy. I should say that these HTML policies are defined here in this file. They are not standard policies. They are just for this demo. And this HTML validating policy will fail if the parameter that is being filled into the template has some invalid characters. And it will just say, sorry, no. But we can go even one step further. We don't need to produce strings from the template. We can produce something better. And in this case, I have a policy that returns some HTML document, which is some maybe AST that describes the document. And it's like an abstraction that doesn't need to possibly escape anything because it correctly represents the text with the like filled-in parameters. And this can be used for, I don't know, maybe JSON. You can have a template, and you could have a template policy that would create a JSON structure for the given template with the given parameters without, let's say, any explicit escaping, any explicit care about some dangerous characters or injection or something like that. So I think this will be useful, but it's not clear when or even if this will be added into the JDK, and it will start as a preview surely. Then let me switch to another group of language features. And this is pattern matching. And yeah, I should probably start with an image. Let's consider an expression language that allows us to declare or write expression, and we have some parser that will parse these expressions into some AST, which is shown here. Basically, we take this plus, and this is a plus node in the AST that has two operands. One of the operands is the multiplication node, which again has two operands. And let's consider that the AST is declared like this. We have some interface node, and we have some like subclasses for the node that are the particular nodes for literal, for a constant value, for the plus that's at node for mul. That should be easy. And then let's have a method that will allow us to produce the value of an AST of a tree, basically an interpreter for this expression. So there is a fairly long path of features here. And one of the features, we have final since JDK 16, and that's pattern matching for instance of. And it looks like this. Basically, instead of doing instance of and then creating a new variable and casting the expression into the new variable, which is tricky and a little bit dangerous because we repeat the type 3 times in this snippet, right? And if we make a mistake, it can fail sometimes at runtime. So we can write this, and it basically means the same as before. We declare a new variable of this type, and if n is instance of @node, we will create a new variable and put and cast n into this variable. Now a question may be why don't we just use flow typing and don't say that here in this block n is an at node. And there are two reasons for this. One reason is that this, if we consider this to be a pattern, it opens up new possibilities for the future. And the second reason is that if you used flow typing and if you would change the type of the variable n inside the block, it would actually not be compatible with existing programs. It would change meaning of at least some existing programs. And let me show you why. I have down here two methods that are both called run, and one takes node and one takes at node. And if n is a node, it will call this method. And if we would change the type, it would actually call the second method. And that's like that's a change in the semantics of an existing program, which is not good. So this is pattern matching for instance of where we have some simple patterns. And let me convert the whole if cascade. And this is final features since JDK 16. In, I believe, JDK 17, we added a new preview feature that is called pattern matching for switch. What I will show here is how it, we hope it will work in 19. It's currently proposed to target to 19. These changes are proposed to target to 19, but it's not approved yet. And what we can do is we can do basically this. And the meaning is the same as for the ifs. If n is an at node, then we will run this expression and return the value. And this is, I think, nicer than it was before. But there is one more related aspect to this feature, and that are guards. So we can add additional conditions on the patterns, or on the cases, more exactly. So we can say, call this code only when some additional condition is met. So for example, we can type something like this. And this means that if the left operand of the at node is a literal node and the value of the literal node is 0, then there is no point in evaluating the left node because it's 0, correct? And this then is a new approach that we hope to have in 19. In JK 18, it was ampersand, but this then is planned and hoped for 19. And we can go at least one step further in the pattern matching story, do at least one more step. And that is, if you look at this code, we are not really interested in the variable an. In the at node, we are not really interested in the at node. We are only interested in the operands, correct, of the at node. So what if we said that we want to split the at node into, no, I did it wrong. What if we said that we want to decompose the at node into the operands, and only if the left operand, the first one, is a literal node, then we want to continue. And we then again have the guard for the value. And these, it's currently called record patterns because it only works on records. And these record patterns can be nested, of course. So we can say that we want to look into the literal node, and we can simplify the guard like this. And it basically means if the variable n, the parameter, is of type @node, whose first component is a literal node, whose value is 0, then we use this case, basically. It may be that at some point we will be able to write the constant here, but that's not being planned right now. And you may know that we can use switches as expressions. So let's try this. We can use a switch as an expression, and okay, just quickly rewrite this like this and this. Okay, it's a little bit longer to do, but it's shorter to read right now, and I think like it still is obvious what this does, and it's shorter and easier to read. And there is another connection with another recent feature, and that is like this switch expression. It needs to be total. It needs to cover all the possible inputs, and so we need to have some default here right now. But we have also introduced recently sealed classes, or in this case interfaces. So we can say that node is a sealed interface, which means that it can only have some enumerated subclasses. It's not possible to generally subclass node. The subclasses need to be specified explicitly, or implicitly in this case, all the subtypes of node must be inside the same top-level class. And in this case, because this switch covers all the possible inputs due to the sealed interface, we don't actually need to have the default, because we have covered all the possible inputs. So there is like a good connection between like pattern matching, switch expressions, and sealed types. Okay, so I think this is all I have for, let's say, language features, or mostly language features. And I would like to take a look at a feature that is somewhere, let's say, between library and a VM feature, and that is Loom, or more correctly, virtual threads. And let's have a motivating example. Let's have a task that connects to an external server. And this server scales extremely well in this case, but it takes 2 seconds to answer. And we have here like run the task asynchronous, and it will take 2 seconds between it asks and and there is a response, which is okay, possibly. But now, what if we want to run these tasks multiple times? Let's call it 3 times, not to waste too much time. And if you write it like this, it will like connect to the server, wait 2 seconds for the answer, connect to the server, wait 2 seconds for the answer. We will spend a lot of time waiting. Like if you look at this code, this process that we are running here is basically not doing anything all the time. It's just waiting almost all the time. So can we do better? As I said, the server is scaling very well. So what if we ran this in parallel? And let's do it. Let's run in parallel. Let's run in 3 threads. And right now we here see another new feature in 19. This new fixed thread pool will return an executor service. And since 19, this executor service is auto-closable, and when it's closed, it will actually wait until all the running tasks finish. So we can put tasks into the service, and it will only leave the Travis resources once all the tasks are finished. And we actually need to pass the task into the executor service, and we need a final variable to pass to the lambda here. And if we run this, we actually run the task in parallel, and they finish much faster. So this works, but what we are using here are platform threads, as they are called. And these threads are fairly heavyweight. They consume a fairly big amount of memory. And it doesn't scale too far. It surely doesn't scale to 1 million threads, for example, in one VM, or maybe even on one computer. And if you would like to know why it's needed, I would suggest to read the app. It's pretty well written. In this case, because I don't want to try to run a million threads here, because it might log the computer, I am running the test case with a very limited amount of memory. And if I try to create 100 threads here, it will fail, or at least it should. So let's try. Yeah, so it failed to create a thread, maybe like 20-thread thread or something like this. Okay, so it doesn't really matter whether it allowed us to create 20 threads or 100,000 threads. There is some limit to the number of threads that we can create. And again, the actual task that we are running is not doing anything, or nearly anything. It's waiting for some external condition, for some external input. So it's unfortunate that it cannot scale to values that we want. So what we can do, we can use some asynchronous API. So I have written something similar in an asynchronous way with callbacks. Okay. There are, I think, 2 issues with this. One is that it's, or two problematic aspects with this. One is that it's complete rewrite of the original code. There is nothing from the original code. It's completely different, and it's fairly maybe difficult to write. It should run. It should be able to do 100 connections in parallel, no problem. But it's like something completely different. I had to throw away the code and write it again from scratch. So can we somehow save this asynchronous approach while still scaling better? And what the virtual threads are aiming for is that yes, we can, or yes, hopefully we can. And okay, I knew this will happen. It always happens. Okay. There is some bug that doesn't like me here. Okay. And I, of course, don't remember the correct name of the method, so let's copy it from here. So there is a new preview method, a new virtual thread per task executor. And this will scale, and I will say what this will do. For every task that we create here, it will create something that is called virtual thread. And a virtual thread is a lightweight thread that doesn't consume too much resources. And this virtual thread will be attached to a platform, to a real thread. It will run until it blocks on maybe I/O or on monitor or on sleep or on something else. And if it blocks on something, it will be put aside, waiting for the condition to succeed, for getting the result. And the platform thread will be used for another virtual thread to run. And when the another virtual thread will be blocked on something, it will be put aside. And once the external condition is met, the threads will be resumed, attached back to a real platform thread, and run again. And with this, we can run, even with the limited memory, we can easily run 100 queries while still having the easy synchronous code. So I think this will be useful for certain type of applications that need to handle many requests at once, where the requests actually are often waiting for some external condition, for example, on an answer on an external server. And now a last feature that I would like to show you is a feature for interaction with the native environment, usually. And it's API to access foreign, usually native, functions and memory. And this, up until 18, it was an incubator API. The proposal for 19 is that it hopefully will be a preview API. And let me show you a motivating example. Let's say we want to read the name of the terminal on which we are running, which is some simple task that we can do. What we would traditionally do, we would declare some native method that would somehow mirror the real function in the standard libraries or in some other library, which is this, which takes the file descriptor for the terminal that we want to query, some buffer into which we will or into which the function will put the name and the size of the buffer. And once we have this native method, we can let JavaC generate some header file, and we can actually write a piece of native code that will actually call the real function in the standard library in this case. The issue with this is that we need to compile this native code for every platform that we want to support. So maybe we need to compile it several times for different CPU architectures for Linux, several times for Mac, and so on. And we need to distribute these native libraries, and that's not that nice. And again, there are libraries that can make this easier for us, but these are external libraries, and often they are not extremely fast. So the question is, can we do better? Can we do, as part of the platform, can we do something that will be more efficient and nicer? And the answer in Project Panama, which is like the code name for this group of apps, or for this feature, the answer is hopefully yes. And it looks a bit, the code looks a bit terrible, but it's not really. So what we can do, we can try to look up from Java, without any native code, we can try to look up a function in a native library, in this case, in the standard library. And we can say which parameters it has, or what return type it has, what parameter types it has, and we can create a method handle that will actually call the correct native function if we pass the correct parameters to it, which is what we are doing here. This is the lookup. This is some signature, the parameters for the method, and this is what will create the method handle for us. And if we want it to be nice, we can create, let me say, facade for this in a form of a real Java method that will be a bit nicer. We don't need to interact directly with the method handle. And if you look here, these are the parameters for the native function, and these are the parameters for inside Java. So these are very similar. And then when we want to use this, we will allocate some native memory. We will call the method, and we will process the resulting value. And now there are several important things to note. One of them is that when we allocate some, let's say, native resources, like here allocate native, we need to be able to deallocate them at some point. Or usually we want to deallocate them at some point, correct? And currently the API does, or the proposal for JDK 19 is that there will be a memory session like this, and everything that will be allocated for this given session will be automatically allocated at the point we close the session. So in this case, it's easy. We use Travis resources to close the session at the end of the main method. So everything that we allocate here will be automatically deallocated at the close here at the end of the Travis resources block. And okay, let me show you that it works. Let me show that it works, and so that we can discuss some more important things here. And as you can see, we run it, and it returns some name of the terminal, so it works. We currently have to say enable preview because it's a preview feature, or the build that I have has this enabled as a preview feature. Because we use, let's say, dangerous methods, we also should say which modules can access these dangerous methods. Because, of course, if you call some native function, it can fail, it can crash the VM if you pass wrong parameters to this. So it's good to like say which code can run these dangerous functions. And now, as I said, this lookup and creating the facade, it looks a bit terrible, I think. The good news is that you don't always need to write this by hand. I did, but it's not, let's say, mandatory. As part of this project, there is a tool called Jxtract that can take a header file for a library and generate code that is very similar to this, or at least somewhat similar to this, that will create these like facades for the native functions for us. So what you see here, it can be effectively auto-generated for us, and all we need to write is this call. This is basically the code that we need to write. This code above can be generated for us by Jxtract. So these are the new features that I wanted to show. And now, okay, let's try to see if there are some questions. Okay, there are. When is Project Loom going to be in LTS? And that's not something I can say, because no one knows, really. The next LTS will be JDK 21, or that should be JDK 21, but whether Loom will be final in JDK 21, I cannot tell, because that's not clear. We can always hope, of course, but we cannot tell. From Yarda, what turns a text block into a string template? Yes, is the backslash opening curly brace that will convert a string literal. It doesn't have to be a text block. It can be a normal string literal. It will turn it into the template, which is basically a string with the parameters attached. Why do you think there are so many applications which do not want to update Java to a new version and still use only Java 8? Okay, I don't know if I can answer that. I don't know. I personally would like to switch to something newer in some cases, but it's decision of the applications, I guess. Is Loom already in preview? Yes, I forgot to say this. Loom was integrated into the JDK 19 mainline on Saturday. So yes, it's in preview in 19. It's integrated. Okay. Whether Java plays catch up with Loom, I guess that depends. What I think is a good thing on Loom is that you can write the code like a simple, synchronous, stupid code. You do not need to take care about manually yielding or anything. You just write the code as synchronous, simple code, and you run it, and it should automatically swap out the thread when it's waiting for some external condition. Okay, OS-wise, virtual threads run on the main. Virtual threads are run on. I believe that virtual threads run on some platform threads. I will admit I don't know the very exact details, but I don't think we can say it's the main virtual thread. There is a pool of platform threads, and they will run on some thread in this pool. Why backslash and not $? Because I would say the simple, maybe not completely satisfactory answer is that backslash curly brace is not a valid string right now. But $ something is a valid string right now. So it's more compatible to do it with backslash curly brace. Are there plans to introduce copy constructors for part of the fields in records? I would say there are many talks, but I don't think I can say yes or no to this. But there are many talks. Seems like Java is trying to keep up. Yeah, maybe. Java is a stable, Java as a language is a stable language, which maybe evolves slower, yes. Lightweight threads, which features they are missing comparing to real threads. Yeah, there are some limitations, and I should know them, but I cannot remember right now. It's not that bad. It's not that bad. There are some limitations regarding thread groups, regarding some like probably obscure methods, like stopping the threads, but it's like very limited for any threads anyway. They work differently in JDI, in the debugger interface, and in some other interfaces because the lightweight threads, like in a sense, don't exist unless they are attached to a real platform thread. So we can think maybe of them as a description of a thread that can be run at some point. Okay. How about variable name erasure in string templates? I don't know. Okay. I don't think I can really compare virtual threads to the Erlang VM model. I am not that much expert to that, sorry. Are there plans to introduce records deconstruction without using instance of? I would say yes, there are many talks, and this may happen, that we could have something that looks like a variable declaration that actually will do the construction, but these are possible future ideas that may or may not happen. Will / curly brace AB work? Yes, it can be like inside the template, it can be an expression. It doesn't have to be a variable. It can be an expression. Yeah, auto-closable executors, yeah, executors are closable, yeah. Okay, I don't know. Yeah. Okay, I don't know if you have time still, or if you should. Excuse me? Yeah, okay, so, yeah, thank you, but we're out of time.